Hello everyone and welcome to Cassandra Developer Workshops. This one is delivered to you by DataStax Developer Relations team. And I hope you hear me well and see me well, because we are going to talk about a lot of very interesting things today. So, loud and clear, lovely. Today we stream at Twitch and YouTube. I hope you have the links. And to ask questions and clarify anything, to discuss everything with your fellow co-watchers, please go to Discord. We will put a link in a moment. So important link for us is the Discord. Please, guys, put it to the chat so everyone knows where we are getting together. Every information will be published in the Discord main chat. Very well. So I hope you got the emails with everything what you need to start. So let's go on. First of all, about the team, we have a great team of 4 people working for you together. That's me, Alexander Volochnev, developer advocate at DataStax, and I will present everything today. And guys are working with us are Jack Fryer, community manager, David Jones Gilardi, developer advocate, and Cedric Lundven, director of developer advocacy. As you may see, it's a very distributed team of very many countries. DataStax is distributed as well as Cassandra does. To distribute workload and distribute everything is very important part of the Cassandra features. Let's move on. So, DataStax asks you to keep calm. That's a lot of bad things happening in the world right now. And we did really great things. I find it. They have our site reliability engineers available for even users of an open source Apache Cassandra. So if you are going to use not only the DataStax Enterprise, but open source Apache Cassandra, you still may go and require some help on the Keep Calm at datastax.com at no charge. And that's great. Cassandra on. So what we will do during this workshop? Main thing for us, we will have to set up everything. We want our workshops to be as practical as possible. So you will do your homework, you will do exercises. That's the only way to make this information, things get really deep into the brain. Do it with your own hands on your own laptops. If you by any reason can't do it, okay, we have video solutions recorded for you. But still, I do ask you to do it on your own. Then, of course, we will discuss main points of Apache Cassandra, why it's the distributed, no master, no slave database with all its cool features. That's the main part of the workshop. We will do the data modeling. Take a look. Cassandra query language is made to be very similar to SQL, so all the people will learn it very easily, and anyone with experience with any of SQL databases, but it's an easy to get into a trap. Cassandra is different. Cassandra is non-relational database, but people make a mistake working with SQL, like, okay, it's easy, I can do everything. Come on, listen to me, people. That's very, very different. So it's very important to you to stay very patient and get all the things out of the data modeling part of the workshop. And then we will discuss some upcoming things with you. So let's start. What's important for us here? On your laptop, you are going to use browser. I hope you're already doing that. And as a web conference, as a tool to discuss everything with people, we use Discord. And Twitch and YouTube are our main platforms to deliver the information and the video stream. So we will have some resources on GitHub for you to use. So on the GitHub, first of all, you have all the slides, so you can use them after the workshop. And the second thing, there are some notebook files you will have to upload to the DataStax Studio we will use and discuss in a moment. So I hope you already have a link on Discord to see what files you will have to download. And we are going to use DataStax Astra. So what is Astra? Take a look. Cassandra is a great database, but it's not the simplest in the questions of setup, keep it running on multiple servers, cluster, and so on. And that's a developer workshop. So we want to keep things very, very simple for you. You don't have to set up anything on your laptop, anywhere in the cloud. Everything is done already for you. So DataStax Astra is a Cassandra as a service. Cassandra managed by DataStax. We use it for these exercises, for the exercises for you to do. So I do hope you are in the Discord to join us and ask questions and get all the links we will distribute. And if you are not, please follow the links. Our great guys publish it for you already. Okay. And of course, feel free to ask questions on Discord. That's why we are doing here, to answer your questions. And first exercise we are going to do today is to set up the infrastructure for all the things you are going to do during the workshop exercises. First, you are going to download repository material from GitHub at github.com DataStax Academy Cassandra Workshop Online. And this link is very important. So what you have to download where, let me show you. We are going to github.com DataStax Academy Cassandra Workshop Online. I will make it a bit bigger so you will see everything what I'm doing. Good. That's the main repo for our today's workshop. So what you need to have, or what you need to do is to download notebooks. So you can download, the whole repo with download zip, or you can go to notebooks folder. And here you have tarballs you will have to download on their own. Notice, you don't have to open those files. We will import them into the Astra very soon. So, very soon you will need the first notebook tarball, DataStax Studio. I hope you've opened this page already and downloaded the notebook you need. It may take some time because we have some wait. Now let us go on. So, two words about Astra. Running Cassandra cluster is not a simple thing. To make it all managed by the experts and simplify everything you are doing using Cassandra, we have Cassandra as a service called DataStax Astra. Today we are going to use it. In general, it simplifies everything with application development. So you don't have to make every efforts to maintain the cluster. You just work with a language you may need to use. You have great drivers to work with nearly every language by DataStax or community, and development tools to simplify all the kind of work to do. And now we are going to do exercise 1 is to create your Astra instance. So I see in the chat we have some issues with the link to the all the things we do. So first of all, we will need a link for the GitHub Academy of the DataStax Academy. I hope you guys all have it. So don't worry, we will do it all together and wait for everyone, so everyone will be able to do it. Now we will need to create your Astra instance. It will be pretty hard for me to show because I already have my Astra instance. So what I'm going to do with you, first thing, you have to register at astradatastax.com. And don't worry, we are going to use a free tier database, so you don't need any kind of credit card or anything. It's just you create a database on the free tier, it's yours forever at no costs. Good, so first on the free tier, I may have only one database. So I'm going to terminate my old one. Okay, it's terminating, and I will create a new one. Notice you have to do the same. First point, we have to use free tier, obviously. Any kind of not free tier will charge you, so please use free tier. It's free forever, data stays there forever. The only limitation, if you completely not use it for a long time, it will be parked, but still just a parking, and only if you don't use it. If you use it, you can start. If you are going to use it again, you just start it again. That's it. Now, location. For me, I'm going to use Europe West 1. If you are in the United States, I guess a lot of people we have from the United States. Okay, choose the one is closer to you. Free tier, people ask very often what runs, how DataStax Astra runs. For the normal tier, you may choose between AWS and Google Compute Platform. For the free tier, we use AWS. And I'm going to use Europe West. That will be not charged. When running, when parked, that doesn't matter. Now, database name, it's going to be Killer Video. And what matters, key space should be Killer Video. Now, please pay your attention. If you use key space name of different username, different than ours, database password different than ours, your experience may vary. For your exercise, for these exercises, for this workshop, we ask you to use the values provided by us. So it's going to be Killer Video. Database username is going to be KVUser. Notice first three letters are KVU. And password is going to be KVP password. So like KVU, big, there, small, and the same for the password. And we confirm password KVP ASSWORD. And I'm going to launch database. So it will take some time because creation of a database obviously takes time. We may need some extra servers to spawn. We may need some extra actions to do to prepare everything for you. But the important point, we don't need it right now. So we will launch your database, and as soon as it's running, we are good to go. Good. So database is active already. Great. That was really quick. So now I have my Astra databases, Killer Video. I can get all the list. or to go directly to my database. And pay attention again. Here, downstairs, you have a button, Launch Developer Studio. That's exactly the place we are going to do all the exercises. So it will be your workplace today. So I'm launching Developer Studio. And I have this studio here. So I'm using my KV user KVP sword. Hope I did no typos. Good. Welcome to DataStax Developer Studio. It's going to work. Now, I have only one notebook here, getting started with Astra. To get my notebooks, I go to Cassandra Workshop Online and I download the DataStax Studio Tarball. Oh, oops. And just push the row button to get it. So the star file is downloaded. You don't have to unpack it. Now what we do, we go to Studio and we simply put the starball here. And notebook is imported and opened automatically. That's the exercise with the studio we are going to do as a second exercise. So again, first point, create your account on Astra. Astra.datastax.com. It's free, out of charge, no credit cards, no nothing. Free tier is endlessly yours. If today you don't have enough time to do exercises with us, then you can get back to these exercises at any moment and use the studio. So don't forget, launch Developer Studio here. Or also you can launch Developer Studio directly from your list of the spaces with just Developer Studio. It will do the same thing. Good. So what I'm really curious right now, if we can go on with the exercises, or we may need to wait for some people to create Astra accounts. But if you are waiting for Astra to be done and your Astra database is created, that's very fine. We can proceed and do the theory. So I kindly ask David, Cedric, do you think we are ready to move on? Are there a lot of questions in the chat? Okay, so let's have a few minutes pause. Please, if you are ready, if you have downloaded everything and you started to create your Astra instance, please set a thumbs up in your Discord main channel. We really wait for it, so to know everyone is with us and we can go on. While we are waiting, for those who are done already, I want to say about a great thing, a great part of this workshop. For everyone who has attended this workshop, DataStax has a very special gift, which is a free voucher to pass the certification exam and get your certification as a Cassandra developer or Cassandra administrator. Normally, this certification costs around $400, like $375. And today, for every of the attendee, we are ready to make this, to give this voucher for free. Absolutely, 100% discount. You will get this link. In a moment, well, not in a moment. For those who will listen to this workshop till the end, you will get the link what you have to do to get your voucher. So stay tuned. Now, I'm asked to show how to import the notebook again. Okay, great, it's very easy. So take a look. I have Astra. I have launched my studio. Now, to import a notebook, you simply go to github.com, DataStax Academy, Cassandra workshop online, and the easiest way to get all the notebooks from this repository, you download zip file, unpack it, and when you have your, I will do it actually. So I have a zip file, it may take some time. When you unpack it, you will, in the folder of notebooks, you will have a bunch of notebooks. So let's take a look. Cassandra Workshop Online Master. There is a folder, notebooks. And what you need to do with them is to simply drag and drop them into the Astra. So here is the Astra, DataStax Studio. So I have this folder. I have those notebooks. What I do is I drag, pull, and drop. This notebook will be imported and launched automatically. To quit them, I press the button on the left top, go to main menu, to notebooks. And that's the same for all the notebooks, but the closest one we are going to use is number 2. So you don't have to import all of them right now, so you will have to do it later. So everyone, how you are doing? Okay, so if you still need time, that's very fine. We will go and make a little pause. I see it goes better and better. Okay, so let's have a 3 minutes pause. That should be fine. Okay, notebook drop again one more time, sure. First thing you do, you create your account at astra.datastax.com. When we create a database with killer video, KV user, KV password, and you launch Developer Studio. So here I have my studio. Then download this repository from GitHub, DataStax Academy, Cassandra Workshop Online. Download zip. As this zip is downloaded, unpack it. So you will have this Cassandra Workshop Online master folder. From there, you need notebooks. those 6, and you just drag and drop them to your DataStax Studio. So whatever you need, now notebook, just drag it and drop from here. I have notebooks number 2 and 3, are imported already. I will get back to the list of the notebooks. When I simply pull notebook number 4, because I have the others already, drag on my file manager and drop it here. It will be downloaded to the DataStax Studio automatically. If your studio is not ready yet, if your database is not ready yet, that's very fine. You will do the same steps during the exercise. During the next exercise, there is no problems. We're still first going to do some theory steps. So we will do it again in a moment during the next exercise. If you don't have your notebooks uploaded to Astra, don't worry, it's not the point. Now we will go and discuss the most important things about the Cassandra. So a little bit of theory first. Exercises are very important, but first we will discuss the theory. So don't forget, if you are ready, put your thumbs up in the Discord. I see more and more thumbs up. That's great. Yeah, that's how it goes. Very good, guys. Thank you. A lot of thumbs up. So if you are waiting, don't worry. The creation of a database, it's not the easiest things. It may need a lot of servers. It may need to deploy Studio for you and so on and so forth. So don't worry. I will proceed. Yeah. Perfect. Still waiting on DataStax Astra to load. That's fine. It will be created in some minutes. We have time. Let us move on. And now we are going to discuss Apache Cassandra, why, what, and when. You know what? Why is one of the most important questions. When you are designing something, when you are going to use a system or build a system, why is the first question you have to answer. So, Apache Cassandra was designed to be a perfect storage solution, perfect database for the conditions when you need to work with tremendous amounts of data. Like Apache Cassandra is the main database for Apple, where it works with dozens petabytes. Like there is a tremendous amount of data. You have some data stored with Apple, mostly probably is going to be stored within Cassandra. And it's designed to scale linearly. We will show it in a moment. And it was designed to work, providing answers extremely quickly, despite any amounts of data you work, despite any amounts of data and load and pressure you have, while working over all the world. Like then you are traveling with Uber, you go to the airport in the United States with Uber. When you land in Paris, well, that's a bad example for these COVID-19 times, but still, like it was just a month ago, you land in Paris and your Uber still has all your data. That's just data replicated over the world. That's how it works. Cassandra is NoSQL distributed database. What does that mean? With a lot of databases, you use it to work. You have a single database server and single database instance. That's very fine, and you still can use it with Cassandra, but that's not the point, because usually we want to have multiple nodes. One node is perfectly powerful. One node installation can store around 1 terabyte. Some people prefer to have less. Some people prefer to have higher density nodes and have output of 3000 transactions per second per core. So multiplied by the amounts of core you have per server. But therefore, we are going to have it distributed, having it over multiple servers. And every node communicates with another node. Those are no master database. Any master-slave architecture has a critical failure like the single point failure. If you lost your master, database can't work anymore. If you have two masters, and if you have network outage between two of them, you have a split brain problem. So Cassandra works differently. One data center with no master servers, every node has the same responsibilities, works together, and there is no single point of failure. I will show it to you in a moment. One of the most important features for us is how it scales and why it's so important. What's so important? It scales linearly. So what's the case? Take a look. This picture on the right, like Cassandra does faster than all the other databases. Well, properly configured it is, but that's not the point of this picture. As an experienced engineer, I can set up every of the database to be slow or fast. That's all in the configuration. The point is, Cassandra does scales linearly. You want more capacity, you want to store more data, add more node, you want to have higher output, just add more nodes. That's very simple. So the secret is it has very low to zero overhead on adding the new node. One of the best research on this field was done by Netflix database, cloud database experts. They simply created an experiment running Cassandra from 3 nodes to 350 nodes. And they had nearly zero overhead on adding the new nodes. Capacity and output processing power was just linearly scaling higher and higher. So that's one of the main important things for us, which I like as an engineer, really happy I don't have to take care of these things. I add a new node, I have more powerful system. Need more, add more. Second point. So there are two main ways of scaling, horizontal and vertical. Traditional vertical scaling for databases works like if you need more computational power, you buy or rent or have in a cloud more powerful server. And the problem of this approach, it goes extremely expensive after a couple of iterations, like extremely expensive. Those who did that already, like have bloody tears in their eyes, they know how it goes with, I don't know, AWS or any cloud or any server provider you are going to use. With Cassandra, it goes differently. We do not recommend to use supercomputers as a Cassandra nodes. That's maybe the most efficient usage. We recommend to just add more nodes of the same power, like medium computational power servers, like X large things. Well, it depends on your use case. And then if you need more power, you just add this node of the same power and the same amount of cores, memory, and so on and so forth. So, oh, okay, sorry guys, it looks like I'm hiding some of the content by myself. I will do myself a little bit smaller so you will see it better. Yeah, you are here not because of me, but because of Cassandra. It's a bit sad, but that's how it works. Okay. So I see a warning what any links are removed on YouTube. So if you are watching us on YouTube instead of Twitch, please open DataStax devs on Twitch, where you will have all the links. But the main thing for us for links and all the discussions is Discord. Good. So horizontal scaling is much cheaper. and works much more effective. If you have 3 very powerful machines, you still have 3 very powerful machines. Like if you are losing, you can't afford losing a lot of them, and it may happen. Everything can broken. When you have multiple dozens of medium size, medium power machines, there is a less probability to lose all of them at once. Let's move on. Oops. So, next point, and that's very important to understand, data is distributed. Cassandra is ready to work with very big data. How it works with usual traditional relational databases. You store a lot of data on a single server. You may have master-slave replication, that's not the point, but still all of your data on the single machine. As long as you have to spread your data over multiple machines with sharding, you start to know what the pain is. And that's really was one of the points with Cassandra to avoid this issue as your data gets too big. And data within the same table will be threaded over multiple machines based on the partition key, and it will be distributed over multiple machines. So you see the nodes, the rows having the same partition key. In this case, it's a country, go to the same server. It's called the partition, and we will talk about it a lot later during this workshop. So, next one. How data is distributed. So, take a look. You may think of spreading data over the nodes, over the multiple nodes, using a property like username will define, not username, but the user first name, let's say, like I am Aleks, will make the partition, and all the users of this name will go to a single partition. It may work technically, but when you will have like some very popular names, like, I don't know, name John, mostly probably going to be overloaded, and name like more rare names will not be so, and then your servers going to be busy. Like in this case, we see what Japan server responsible for Japan will have only one record, and servers like in the USA or in China will be much more busier. So to avoid that, we have a partitioner which hashes the value of you are using, and then based of a created hash, this hash will be used as a partition key to define the partition. So for example, if we have like CA as a partition key value, it will be hashed into some integer, very, very, very long integer, and then it becomes a partition token which defines to which server data goes. If you didn't get it right now, don't worry, we will get back to it. So, how the ring works. In this case, we have a data center, or a ring, how we call it, of 6 servers. And every server is responsible for one set of data. So like from 0 to 17, from 1 to 17, the blue server will be responsible for the data of these token ranges. Next one from 18 to 33, and so on. Of course, usually those numbers are much longer. And those are big, big partition IDs. Good. So when data comes, for example, partition 59, every node works as a coordinator. So every node is able to answer to any question, but in this case, node responsible for this range of 68 to 83 is not responsible for data of partition token 59. So it works as a coordinator node and sends data to a proper node which stores this data. And this node storing your data is called replica node. It happened to store all the data of this token range. But the point is, no one uses Cassandra this way, because data is not only distributed, data is also replicated. You want to have your data available all the time, aren't you? So the only way to grant it is to distribute and replicate your data. So we put your data into multiple servers in multiple copies or replicas. In this case, we have a replication within the data center or within the ring, and replication factor is 2. So every server is responsible for 2 sets of information, for 2 token ranges. And as you can guess, it basically leads you to the situation where data consumption and storage place consumption grows twice. And that's very fine. Disk space is cheap, but availability of your data is usually critically essential for your business. And in this case, when data comes, like again for the same range, coordinator node will replicate it to multiple servers. So two replicas are available, and 2 replicas will store this data. But we usually recommend to use replication factor 3. That's because of the consistency levels. Consistency levels are very important, and we will talk about them in a few minutes. So with the default value of replication factor 3, you are going to have your data replicated 3 times. It means what you can afford losing one of the servers, and your data still will be available. So when data comes and one of the servers isn't available, coordinator node will send data to all the available nodes and store so-called hinted handoff for the failed node. Doesn't matter what exactly happened, like power outage or network issue or anything. As soon as node reports what it's fine, coordinator node will immediately dispatch the hinted handoff, so node will become active with all the data recovered very soon. And that's one of the many mechanisms of self-defense in Cassandra. Cassandra is a piece of art from engineering point of view. It has incredible amount of mechanisms to protect itself and get all the data on time for you. Again, few words about it in the later slides. And next one, and this one is great. If any of you have experience doing master geographically distributed replication with relational databases, you guys will absolutely love this thing, because geographic distribution makes me having multiple data centers all over the world in nearly every place, and all the data will be distributed automatically, and that doesn't matter where exactly I write. It's fully active in any direction, and that's great. So no more pain with replication for relational databases over multiple data centers. It works really great, really smooth, and that's a native feature. That's lovely. Then we aren't talking only about geographic distribution. There is one more thing to cover. Cassandra is platform agnostic. So you can have one ring on the Microsoft Azure, one ring on AWS, one ring on Google Compute Platform, and one ring everywhere on your own, like on the whatever you want to use. It's absolutely native, absolutely seamless, and works perfectly. What's important here? Take a look. I'm located in Germany, and European rules and laws like these GDPRs are very strict. For Germany, I have to store data of German clients on the territory of Germany. So when, okay, no problems. I create a key space with a replication factor only for the German data center. I will show it in a moment. And data of my German clients store it only in Germany. And boom, I'm GDPR compliant in just a few clicks. That's like extremely great feature for everyone who understands what's the issue of GDPR. They know like how much pain in it. So there is one very important thing we have to understand working with distributed systems like Cassandra, but that's about any distributed system. And if you are working with distributed system, or if you are creating distributed system, you absolutely must know this CAP theorem or Marx-Breuer theorem. In the perfect scenario, the network is perfect, power is always present, servers are never lagging, you may be at the same time consistent, available, and partition tolerant. And yes, you may laugh now because network is never perfect. Electricity disappears sometime, and all the other shit happens in your data center, on any cloud, and so on. All data center are being wiped from time to time. So in the perfect scenario, we can be in the center. What says CAP theorem? In the real world, you in the distributed system cannot be at the same time consistent, available, and partition tolerant. That's just not possible. You have to decide. So what's that? Partition tolerance means what your system can tolerate, like so well-known split brain problem, like part of your system is not available. Well, they both are available, but network is unavailable from one part to another, and then you may be in big troubles. You don't want to have the system which is not partition tolerant if you are working with a distributed system. So we can't give up this feature. And then you have to choose between consistency and availability. Then the data comes and your server is not available for any reason. One of the servers storing this data, like one of your replicas. Then system have to decide, or it will answer you with the latest available data, which may be in theory outdated, so it stays available but may be potentially not consistent or eventually consistent. Then you go with availability and partition tolerance. Or you can go with consistency and partition tolerant, then system will drop your query and say, one of the servers responsible for data is not available. I cannot react to this query. It's not, may not be consistent answer, maybe not consistent. So then our query will be dropped. So Cassandra is available and partition tolerant by default, but I wouldn't call it AP because it's configurably consistent and working with consistency level and working with the configuration for the database, you can move it to be consistent and partition tolerant. But then you risk losing some servers to be not available anymore. So in some cases, you have to decide between consistency and availability. Good thing, Cassandra is very well designed for you to make the decision. So you can make a decision based on the very query level. The same application works with different kinds of data, and you can decide what do you want to have. Don't worry. So consistency level, that's smooth. Take a look. The same application, as said, may work with very different data and data of very different importance. Like, for example, one application may work and store your profile picture, and the same application is responsible for storing your financial data. When you work with financial data, of course, you want this application to be very, very, very consistent. And when it works with like profile picture things or anything like that, like secondary importance thing, that's very fine if your profile picture will be updated in a second, in half a second. That's completely fine. So let's get to the example. Consistency level 1, how it works. We have a cluster of 6 nodes running with replication factor 3. Key space with replication factor 3. So every piece of data is replicated 3 times. And we have an incoming query with consistency level 1. Don't forget, you can configure consistency level per query. On the application level, it's very easy to set. So client writes, for example, and coordinator node sends the data to the 3 replica nodes responsible for this piece of data. Then with consistency level 1, it waits for only one acknowledgement. So all the write requests are sent asynchronously, of course, but we wait only for the first response. And then confirmation will be sent to client. Okay, we got your data. Benefit of this approach, of course, it's the fastest. So if network works perfectly, all the nodes will react within the same time, and it's fine. But in this case, we don't want to wait for anyone because some nodes may be busy, some nodes maybe have some latency on the network. We got the first confirmation and we dispatch it to client. Consistency level 1, we are done. Okay. So, as you can guess, it may lead to some problems because our nodes may be not confirmed because we haven't got this query, and when we run into inconsistency. So, the default consistency level into the Cassandra is quorum. And with replication factor 3, you can count very quickly. Quorum, so the majority of the nodes will be 2. That's why we recommend to use replication factor of 3, or in some cases 5. So you will have quorum of 2 or quorum of 5. Quorum of 2 or quorum of 3. When with replication factor 3 consistency level quorum data comes, it will be distributed to all the replica nodes, but we will wait for majority of servers to acknowledge, to confirm the data has been written. And that's the default Cassandra behavior. So when we got 2 confirmations, confirmation is delivered to a client. Client knows what data has been stored. And third server will react and acknowledge it on time, but coordinator node will not wait anymore and dispatch confirmation immediately. And the final point is the consistency level all, and I bet you understand what's going to happen right now. We send the data to the replica nodes, and we wait for all of them to confirm the data. And some people think, wow, this consistency level seems to be the best, and I'm going to use it all the time. No, that's going to be very, very, very bad idea. There are 2 points to consider. Do you remember our consistency availability partition tolerance theorem? As soon as you prefer full consistency over availability, you become fully consistent but not highly available anymore. So in case of any of your nodes are not able to react on time, then you just got an error. Sorry, we don't have enough nodes to process your query. Consistency level is not reached. And well, I want my data to be consistent. How it works? Well, first of all, Cassandra has a lot of self-defense mechanisms and repairs to deliver all the data to all the nodes in a proper time, like hinted handoffs. This failed server will get your data on time. But there is one more important thing you have to understand. That's not necessarily to be consistency level all to still be fully consistent. Take a look. You are fully consistent, immediately consistent, not eventually, but immediately consistent, when consistency level of your write plus consistency level of your read is higher than your replication factor. So take a look at this example. Same example, replication factor 3, consistency level discussable. So for example, for the quorum here, I send the data to 3 servers. 2 of them got the new data, and they are good. And third one, let's imagine, didn't get this data. And when I'm trying to read this data with a consistency level quorum, in the case, I ask 2 updated nodes, give me my data, when I will get updated data. It's fully consistent. And if by occasion I ask wrong nodes, still because I use quorum with replication factor 3, which is 2, I always ask 2 nodes. And if one of them has outdated data, coordinator node will see it, initiate repair on read, and deliver you the updated data. So with the consistency level quorum plus consistency level quorum, it's always going to be higher than your replication factor. You are fully consistent. And you still can afford losing a server completely and dispatching and getting always consistent data. And if you have replication factor 5, then quorum is going to be free. Free consistency level on read, free consistency level on write. 6 is still higher than replication factor 5. So you are fine. One more case, in some very rare use cases, you may want to do write once per day and then read very, very quickly. Then in this case, you may have consistency level all on write, then you can have consistency level 1 on read, which is still going to be higher than your replication factor, because level all is going to be 3 on replication factor 3, and level 1 is going to be 1, obviously. So you have 4, which is still higher than 3. But that's a special use case. That's not the traditional workload, let's say. But it's possible. So think of the consistency levels of your queries. And again, consistency level is not defined per database. Consistency level is not defined for a key space or table or anything. Every time you send a statement like insert into, select from, you can specify consistency level you need right now. And that's great. Great, so we just discussed it. Then, after all of this, we can get to the use cases of a Cassandra. So for those use cases, it was created. Take a look, there is no silver bullet in the software development. If anyone says you what this database is perfect for any use case or that, don't trust, that's all bullshit. That's very important to understand what's the hammer and when to use hammer, when to use French, and use proper tools in a proper time. So every time you need scalability and ability to handle any output and any volume, especially when it changes. So in the beginning you have small amount, in the end you are going to have tremendous amount. Or heavy writes, heavy reads. So again, scalability, but about output, not volume. Cases like event streaming, logs analytics, Internet of Things with billions of queries, any kind of time series, and write-intensive operation, read-intensive operation, that's a perfect use case for Cassandra. Cassandra, if data model is designed properly, is very good for any kind of these activities with scaling for both amount of data and amount of operations. Availability. You have seen already, having your data replicated with replication factor 5 on 5 servers, you can replicate data. You can afford lose 2 servers and still have all your data available using consistency level quorum, which is the most default one. And good point, don't forget, geographical distribution is also goes to this. You may have a disaster, like real disaster, wiping out a data center, and still have your data available in another data center. So any kind, then the availability of the data is mission critical for you. First, no data loss, and second, always available. That's very Cassandra use case. So for any kind of data, you are going to need always available in the same second, in the same milliseconds. It's your use case. Distributed. Global presence when you have clients in Australia, China, Europe, United States, South America, any kind of this. Global presence is exactly the case for us to be everywhere with Cassandra. With smooth master, no master, active replication, it goes very smooth. Compliance and GDPR, as said, you may have your data exactly in the data center you want it to be. No more additional data centers and no fighting with the databases trying to put your data exactly where you want it to be. You want it to be in the Europe, you will have it in Europe. Very easy. So all kind of banking, retail, tracking, logistics, customer experience, and so on and so forth. And then last point for us, cloud native. Cassandra works perfectly in any kind of a cloud. So you may have it everywhere, and AWS, GCP, you name it, and meanwhile in your own server. And that's very fine to have it everywhere. Well, any kind of modern cloud applications will find it very easy working with Cassandra. So, time for us to do the exercise 2. Time for you to ask the questions on Discord. Please, guys, I do ask you, don't ask questions on Twitch, don't ask questions on YouTube. Your job is to ask questions on the Discord. It's the main storage, main collaboration point for us. Seriously. So, one more time, let's check few points, and when I will do this exercise with you. First thing, using DataStax Studio. First point we are going to need is DataStax Astra, and I do have your Astra is available right now. Okay, looks good, at least for me. Second tool we are going to need after, as your key space and database is created, we are going to go with Developer Studio. Third thing, you are going to need notebooks from Cassandra workshop online at DataStax Academy. And fourth point, you are going to upload notebooks to these to your instance of Astra, and the uploaded notebook will be opened automatically. If you want to change notebook, like if you uploaded multiple of them, you go to main menu, notebooks, and well, choose the one you need right now. Right now we are going to work with Cassandra Developer Workshop, exercise number 2, DataStax Studio. Good. So I see no more question regarding how to use Studio. It looks like everyone. And as there are no more questions, we can move on and do the exercise. So this exercise, you can just follow me. It's not so important. I will briefly explain what's the Astra, what's the DataStax Studio is. So we will go with setting up notebook first. So there is an empty cell, not really empty, but hidden cell. I will run this cell to get everything prepared for myself. And you know what? I don't want to have anything hidden from you. I'm going to show you code editor. What we are doing is we are just getting ready to work with our first table we are going to use later. So we create a table. Good. And what's important for us first, DataStax Studio is a web interface to work with Cassandra, to do the exercises, for example, or run your things with Cassandra. So we need to know about the cells. Notebook consists of cells. For example, this cell is a type of SQL, and this is a type of a markdown. And actually we may have more, but for this exercise we have only 2 kinds of cell. Markdown cells explain you what to do, and in SQL cells you run your queries. And that's the most important thing for us. For now, you can investigate it all on your own, but there are no important really things. So just think you need to know how to use your query for the next exercises. So you have query explaining what to do. For example, finally, type the command describe key space in the newly created cell and run the code. So I already have cell for it. I can type describe key spaces and run it. I can run it with shift insert, or just run it right here. The result is the same. Here I can choose some more complicated things, but now I will stick to Theorem. And I see what I have described key spaces. I have following key spaces. And that's another important thing for us to do and to understand is what we have schema management tool right here on the right top. So I can open schema management and see all of my tables and see, okay, not so many tables right now, and see all the other things I may have. So in the future, you may use this thing to investigate things in the key space. So killer video key space I'm having right now. Good. Then next point. Basically, that's it about the notebook. You can do a lot of great things with DataStax Studio, but for now, all the things we need to know and we have to do is for Markdown pages, Markdown cells we read, and for SQL pages, we can exercise and do the job on our own. And we use schema to work with tables to see the tables. We can also do some job in the SQL cells. So I can say describe key space killer video. So I run this cell and I have everything what was used to create key space killer video. Then what's important for us? We discussed everything, the points with DataStax Studio. I will not make a deep dive. We need only very simple things right now. DataStax Studio is simple. Read and do what you are asked to do. So I will give you one more minute to catch up and we will move on. So I see there are problem in the chat happened by many people. If you have an error, user KV user has no create permission on key space name, it means what you used a wrong name for the key space. Key space name should be killer video. Good point. If you run into this trouble, it can be very, very easy to fix. Within your DataStax Astra, you can simply terminate this database. It will take half a minute. And you can create a new case by using proper values. So KV user, KV password for user and password accordingly. And key space name is killer video. So yeah, David HS, you are very right. Yeah, it was wrong key space. So just kill the old database, create a new one on the free tier. That's no problem. Usually it takes around 10 minutes. There is a question, what's the difference between consistency level modes, local quorum trace, and local one? So, very simple. Local quorum, local one, it means the desired consistency level you want to choose. Like for local one, you are going to wait confirmation from only one node, and for quorum, you are going to wait for a confirmation of 2 nodes if you have replication factor 3. Local quorum trace works like quorum, but it also dispatches some trace information to get some extra data of your request. And then I want to say a word about one more thing while we are waiting for everyone to handle this. When we are discussing consistency level, there is one more thing. Now we are discussing only consistency level 1 quorum all per data center. But when you work with geographically distributed system, it becomes more complicated and more configurable. So you can decide, I'm going to use, there is a local and each new key space, new words for you. When you have your application for your American clients running in the United States, you don't want it to use as a database which runs in China. So your local data center will be also one running in the United States. And when you can say local quorum, it will mean majority of the nodes running on the local data center. And then you may want to have each quorum when you need to get a confirmation from every of the data centers. But take a look, it may take a while. So we recommend to use things like each quorum with every data center very carefully, because, well, it's going to be kind of costly in the questions of time. So I see we have an issue with stream. Don't worry. Let me try to restart it. Okay, so I'm restarting the stream. Hey everyone, do you hear me? Do you see me? How it goes on YouTube? How it goes on Twitch? YouTube is back. Great, thank you. And Twitch should be green. Twitch is starting back. Great. So what I just said, to repeat, when you work with only one data center, you use consistency level like 1, quorum, all. Not recommended, but still you can if it's your use case. And when you work with multi-data center deployment, you may use also local quorum or each quorum, specifying which data center your particular instance application must work. The point is, when you are globally distributed and you have your application running everywhere, you don't want American instance of your application to use as a database Chinese data center. So you definitely wanted to work with a database in the United States. So when it goes with consistency level local specifies the local data center, which one your application should use. And each obviously specifies every data center. If you want to have guarantees your data is distributed everywhere, use it with cautious. It may be quite a long operation. Okay, so let's move on. Rajesh, okay, thank you. Cedric has answered already. A local quorum trace specify application should work with local database, consistency level quorum is required, and trace to enable trace information about how query went. So you will have some extra debug. Let's move on. Enough questions, at least for me. I will move on to the next part. Data modeling with Apache Cassandra. Now, so for some of you, it's the morning, for some of you, it's midday, and for some of us, it's the evening already. Now, the most important part of the workshop, so please stay focused, stay very with me, and listen very thoroughly. Data modeling is very important. Why? So, Cassandra offers you great features. Automatic geographically distributed replication, highest performance, highest volume management, and so on. But you can ruin it all with data model done wrong. So I very ask you to focus now and watch how we do and recommend to do data modeling with Apache Cassandra. It's different. So as we discussed before, Cassandra uses partitions. So in the relational database, most of you use it to use. You have a database, you have a schema or how it's called, a database by itself. Then you have tables. Then you have rows storing some values. With Cassandra is a little bit different. Because we know we are going to work with tremendous amounts of data, and we have to be ready to handle big data within very, very microseconds, milliseconds. We have to spread and distribute this data over multiple machines. To do it, we use partitions. You can think of partitions in comparison with shards of relational database. But believe me, partitions are much well organized and they're fully automatical. When you add a new computer, new server to the cluster, you don't have to care to spread your data again, to reshuffle your data, to have your data on the new machine. That's a Cassandra responsibility. If you are the one responsible for adding a new servers, you will love this feature so much. Just add more and you have it running with Cassandra. If you are going to decommission node and drop a node like you don't need it anymore, okay, that's perfect. You just warn Cassandra you are going to decommission the node, and it will automatically reshuffle data, recalculate token ranges, and put your data to multiple machines. Lovely. So that's table data. Key space contain tables. Tables have rows, and group of rows colored partitions are stored together within the same node. Each row has a partition key, which is one of the column hashed by a partitioner. So rows, columns, partitions. Very good. So we have a table users by city of the columns city, last name, first name, address, and email. Who can guess which field we use as a partition keys in this case? That's a very simple question. I will not even wait for the answer. We have a city as a partition key. Very simple. All the users from the same city will be stored within same partition. What we have to remember designing the partition? Partition is an essential thing. The main things we remember. First, we will want to avoid partition to be too big. Imagine you are selling some things like a little shop, let's say, or working with Europe, so some multiple countries. Countries usually aren't so big, and you have your customers partitioned by country. It looks like a good idea, and everything works good, but at some point, you start to sell your things in China, and congratulations, you are very successful. That's great, your company gets a lot of money, but now we have a problem. Take a look. Partition responsible for China gets too heavy and too much customers. And then, as this partition, all these rows of this partition are stored together, they are stored on the same servers, and those partitions are getting too big. So it's very hard for this node responsible for this thing is to handle this data and process all the operations required for this. Second point, as the data is stored together, it's not only about the volume. So you don't want your partition to be only just too big, which is bad. What can be worse in this case, then all your customers actively working with the same partition without touching other partitions. It means what servers responsible for this partition will be overloaded, and servers not responsible for this partition will be idling. So you have to be very careful choosing your partition. Like, take a look. It doesn't matter if you have 5,000 servers within the same cluster, which is a very possible thing. The point is, if you have replication factor 5 and you have one partition which is very heavily used right now while others are not touched, you may add 5,000 more servers. It doesn't matter. Replication factor is still 5. So you still have your same data distributed only by 5 servers. So it's very important for your partitions to be reasonable. Doesn't matter what exactly, it's a city name or username, it will be hashed, but that's very important to understand. And last point, talking about the partitions. Partitions, we tend to store within the same partition thing we usually retrieve together. Take a look. Imagine we work with YouTube, and YouTube has a lot of videos and a lot of comments. We tend to store together within the partition things we usually fetch together, because when that's a query for one single server, I don't have to gather information piece from that server, piece from that server. I just get the data from the main server, which is the most important to me. And then I get all the information from the single server. I store all my comments per video with the partition key of ID of this video. What it gives to me? As the partition is going to be based on the video ID, all the comments for this video going to be stored together. What gives to me the thing, what I just load the data, I do one query to one single server, and it works very quickly. I don't have to combine it from multiple servers. So, okay, partitions, rows. What important thing for us as well is clustering column. Together with a partition key, clustering columns define the primary key. I will show it in a moment. And those are clustering column for the sorting order. And that's an important thing. Cassandra is very well optimized for reads and for writes, both. And with clustering columns, you define the sorting order for the data to be sorted immediately on the time of a write, and then data is sorted in memory. Then it's stored in this sorted order. So when you are retrieving this partition, it's sorted, in this case, by last name and first name. Already on write, you don't have to sort anything. It was sorted. That makes read very quick, even when you sort things out. Good. So table holds many partition. And in this case, city will be a partition key for these users by city thing. Key space is the core container for tables. And key space in SQL is defined, creation of a key space in SQL is defined by create key space name, create key space name with replication class, replication factor. So it's going to be very simple here. Key space name is just a string, no secrets. And those are very interesting things: replication strategy and replication factor. Basically, nowadays we have two replication factors, replication strategies: network topology strategy and simple strategy. Simple strategy is good for your laptop and bad for anything else. You're definitely not going to have simple strategy on production. I hope you aren't going to. Seriously, it's a very bad idea. But what we do is network topology strategy, and that's a very smart thing. That's an incredible thing. Then, network topology strategy, as it says, is aware of network topology. What does that mean? When you specify for a data center 1 replication factor 3, it will store 3 replicas on the data center 1. And if you have 2 data centers, you specify for the data center 2 replication factor, well, let's say 3 again, you want them to have to be similar. And 3 replicas will be also stored in a data center 1. Now, it's so smart what it also considers not only data center, but also server racks or availability zones on the data centers of cloud, like AWS, for example. So if you are using network topology strategy on the AWS, you are using so-called AWS snitch. That's not a part of a developer course because that's about operations, but you must know. And within the replication factor 3, every next replica of your data will be put to the next available server rack, or for AWS, availability zone. And that's great because you don't have to care of it. It spreads data evenly, and everything works without your efforts to have it running on the multiple things. If you don't have experience with site reliability or things like that, why you put data into different server racks? Situation is very simple. Within the different server racks tend to fail together because of power outage or anything. So we distribute data not only on the data centers, but also on the availability zones. Then, creating a table in SQL. When we create a table, we are going to specify, obviously, table name. We are going to specify column definitions, primary key, partition key, and clustering columns. Few words about that. In general, definition should look very familiar to you because, well, it's very similar to SQL. We use type text for all of our columns in this case, city, last name, first name, address, email. It doesn't need any kind of other things. What we need to focus on right now: primary key, partition key, clustering column. Primary key consists of partition key. That's necessary. You must specify partition key. And any amount of clustering columns. You may have 0 of them. That's not a real requirement. But in the end, primary key must be unique. And take a look. Funny point. This primary key is very, very, very bad. Like awful. Never do like that. That's a very bad slide. Who can tell me anyone in the Discord chat, why do you think this primary key is very bad? I do wait for the answer. So I see some people are typing already. Duplicate city names, well, a little bit more complicated. Yeah, guys, you are with me, that's great. Big pop in cities. No, that's not a problem of the text. Multiple elements, it's very fine. Because it's create wide partitions. Well, yes, but usually cities aren't so big, so we can handle it. But yes, only one. Yeah, that's well, it's not the perfect primary key in general, but the first answer I was looking for, only one person with a name in the same city. Thank you, Heman GP. Sorry, I don't know how to pronounce it. But it's very, yeah, and there are more correct answers afterwards. Primary key must ensure uniqueness. And this primary key is very bad doing this because if you have the same, within the same city, some persons with the same last name and first name, which is definitely going to happen in the city like New York, then obviously, thanks to upserts, we discuss it a little bit later, you will run into some issues. So, regarding the wide partitions, to big partitions, it's also correct answer. It was just not what I'm looking for. You will not have problems with wide partitions if you are wiping data of your clients, where will just quit. So, but yes, city may be a too big partition. Not in this case, because this table features small amount of values and volumes. They aren't going to be too big because you just store some text and no one has name of 1 billion characters. So wide partitions not going to be the worst thing here. But in general, yes, we tend to have our partitions smaller because some cities may have like 20 millions, or I don't know, what's the biggest city in the world? No idea. So, good. Let's move on. And now I'm a bit tired, and that's your time, people, to do your job. We are going to go with exercise 3 and working with SQL. And now that's your job to find some things to do. And we have 2 options for you. Option 1, you can do your exercise on your own, and that's exactly what we recommend you to do. As a second option, you can just watch the solution by the link appeared on your screens, just bit.ly/cdv Cassandra developer workshop -ex3, exercise 3. On this link, you will find the solution video, so you can just watch it and enjoy. And don't forget to ask questions. I will join you in a chat in a couple of minutes. Okay, we are back online, and I hope everyone is done already. So I see what one of the most often questions here, how to set up a notebook. I see a lot of people are missing very important step, without which nothing will work as expected. So let me show you one thing. Here in the DataStax Studio, in the notebook free, first step is going to be set up the notebook. Choose the next SQL cell and execute it. So that's the setup guide. And that's the next SQL cell. This one, I will make it a bit bigger. And to execute this, as it said on the picture above, you need to click here to execute the cell. So click right here. Then the source code behind the cell is going to be executed, and you will have your notebook prepared to do the exercise. It may take some time, that's not a question. And then we can start to use our cells. What's going on? Yeah, so success, 17 seconds, no data returned. What we have inside is just preparations for the table and loading the data we need for this exercise. So if you are doing something but you don't have required tables, rows, when mostly probably you haven't executed this cell. For the next exercises, please do it. Don't miss it, that's an important one. Now, allow filtering. I see a question about allow filtering. There is a thing to answer allow filtering. It's a part of the next workshop. It's a part of the next steps. So I will explain it in the next operation. But if you are so curious, you can't wait, I'm going to show you, to answer to you right now. So then you have, you remember we discussed partition key? Yes. And you remember we discussed partition. Partition is the thing what defines how data is grouped together. And there is a very important point. Then you have your data spread it over multiple servers based on the partition key within multiple partitions. And you query, I need all users from Phoenix with the last name Smith. Will it work? Yes, it will, because from the very beginning, Cassandra driver of your application, or at least a coordinator node, knows schema allocation, and it knows which node to ask. So which node is responsible for Phoenix in this example, and which node is responsible for Seattle. But then take a look. You are asking, select all from users by city where last name is Smith, without specifying city. And imagine you have some billions of users and you have really a lot of data over thousands of servers. Tell me, please, how Cassandra should decide which server to ask. I will tell you, there is no way to decide which server to ask. And it will ignore your query. That's a Cassandra self-defense mechanism. And it'll tell you, no partition key provided. I don't know which server to ask. Go make a better query. And if you want to force Cassandra to ask for every server in the cluster, you maybe know Mr. Smith, then you go and use allow filtering. And then Cassandra will do this query. Obviously, you're going to wait depending on how many servers you have in your thing. And that's just loads your cluster a lot. So single query will be distributed over multiple servers to get all Mr. Smiths of the United States or whatever country we mean. So think about very seriously. Cassandra is designed to big data, to work with big data, and you have to think big. and you have to stay safe, and you do not want to use allow filtering. If you see any of your colleagues using allow filtering, stop them. Like, that's not how you work with Cassandra. If you must use allow filtering in order to make your application running, that means you did your data modeling wrong. And that's exactly the point we discuss here right now. Do not use allow filtering. Do not destroy Cassandra performance. Good. So we are going to move on. It was exercise 3, and we are going to next step. So I hope most of you already have experience with relational modeling, like with MySQL, PostgreSQL, Oracle, or whatever SQL database you may name. The idea for developers, at least, is mostly the same. You are using SQL. So when we design a model for the relational database, we first think of our data. We first think about, I just get warning. So we received a notification what Twitch has issues, and if Twitch repeatedly hangs for you, just migrate to YouTube. I hope our guys. David, could you please publish a link to YouTube on Twitch? I will be very thankful to you. Yeah, so if you use Twitch and Twitch behaves bad for you, that's how replication works. You just go to YouTube and go watching the same workshop. Isn't that incredible? Sorry for the interruption. So with relational modeling, you first think of data, what you have, of entities, what you work. I mean, like real life entities, employees, customers, objects, selling, orders. So the real world data. Then based on this data, you create models. So if in this example, we think of employees and departments, then you think of the employee model and department model. That's simple. And then you start to use this model in the applications. And data is very well normalized. Usually we speak up to 5th normal form. So no data is copied, all the data in the single element. So you just have table employees, you just have table departments. They are linked one-to-one in this case. So one employee works only in the one department. Well, in the most of the companies, I hope. And then if you need to go and get information about an employee, you make select all from employees, left join, department, blah, 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 blah. So you are using joins to get the data together, and then you use it in the application. I have a little question here. Does maybe happen, any one of you knows what's the highest potential limit of joins in a single MySQL select statement? How many of joins you can use in one select statement in MySQL? What's the maximum number? Try to answer in main chat, please. $64, 100. Okay, very close. Usually people are giving smaller numbers. 256. Good. So maximum limit of joins within the single select statement of MySQL. At least it was like that 5-6 years ago. Maybe something has changed. Was 61. Can you imagine a select join statement with 61 joins? Which kind of, oh yeah, I see answer 61. Yeah. So some of you know the pain. Can you imagine how long it's going to work on a single machine? But now try to imagine how long it's going to work within hundreds of servers. we don't have joins in Cassandra. We do not have any kind of joins in Cassandra because it will affect your performance unpredictably. So there is no joins on Cassandra, and therefore we cannot go with this model. So how do we develop models for Cassandra then if there is no joins? Exactly opposite. So this slide, I have to change it, seriously. This slide says application first. But come on, guys, that's wrong. Seriously, that's wrong. What should be the number first in any system? Clients, users, attendees, guests, customers, you name it. But please don't think of the application first. Think of the people first. People, that's what matters. So I start to think of the people are going to use my application. And how exactly we are going to have, how exactly we are going to work with this thing. Very simple. First, I think of user behaviors. First, I think of a user workflows, how exactly they're going to use the system. Login, register, open this page, open that page, buy something, sell something, whatever application you develop, you know better. Then, based on the user behavior, we start to think of the models, like we discussed fetching data about the company employees before. You see the new table here, first name, last name, department. That's all together. And when I have a model responsible for this workflow, I arrange my data accordingly to this model. And I already see some of you in the chat saying very correct words. Yes, it is a denormalization. What's that? Oops. With normalization, we tend to have every data in the single element. We have department list of departments. If we have one engineering department, we will have only one instance of this thing. And if we have employee, we will have Edgar, Code, Raymond, Boyce only once. And it all works well. It all works great, but there is a problem. Denormalization, answer it this way. On the with the normalization, when you write data, you write it one time. And when you read data, you read it multiple times. So basically what join does, it reads from every table you do. So every next join is a reading from next table. Every next join makes your select query, read query a bit slower. More you have, more problems you have. Denormalization does it exactly opposite. You have to update application multiple times, change or add department in multiple tables, but then you are reading, you have to read only one table. People ask me, who has to take care of the data integrity if we don't have joins, if we don't have foreign key constraints? The answer is you. But seriously, application developer is the one responsible for data integrity. Remember the CAP theorem? It's the same problem here. When you have your data replicated and distributed, the only way to guarantee things using with joins and normalization are locks. And any kind of locks on the distributed system leads you or to inconsistency or mostly probably lower availability and always to very slow performance time. And Cassandra is designed to be very quick, always. So denormalization is our answer to work with. Let's go. So then how exactly do we develop data model for the application? First thing we do is we think of a conceptual data model and application workflow. Conceptual data model is exactly the thing we used to do with relational database in the very beginning. Those are entities we have, what properties we have. And application workflow, as it was said, those are customer workflows what exactly our guests are going to do with the application. Then, holding it all together, we bring in conceptual to logical, binding them together. That allows us to create a logical data model. Then, thinking of a logical data model, we go to physical optimization. And when we go to physical data model, finally in the end, so we are ready to create table. Don't worry, I will explain it step by step. So, with conceptual data model, we think of entities and relations between them. With the application workflows, I think of people and queries. Conceptual data model is about what properties entity has and how it relates to our in other entities. So in this example, we have user commenting on videos, and videos is being commented by user. And user have some emails, IDs, and so on. And video has ID, title, description, and so on. Then on the application workflow, we think what we will need, we are speaking about read operations now, just to simplify. We have to be able to find comments related to target video using ID, get most recent first because we want to show the latest comments, and we will need paging, like one of the requirements. And also, second workflow, we must think of, we need to find comments related by user using identifier, user identifier. Get most recent first, paging required. Why we need to be able to fetch comments by video? It's very simple to explain. The user opens a video on YouTube and sees comments for this video. And some of them are disgusting, but that's not the point. But why we need to be able to find comments by user? There are two use cases for that. Then I'm a user opening my profile page. I want to see all my comments, to see rating of the comments, to see answers, and so on. And second use case is for moderators. Like if I suspect users spamming or sending some inappropriate comment in comments, I want to open comments page for this particular user to see if like multiple comments for the last hour were inappropriate, when I mostly probably going to suspend this user. And we also need to implement CRUD operations, but I want to keep it simple for today. So what's going on then? As we know the workflows and entities and relations between them, we start to think of the two queries, or maybe, well, let's speak about this first. We are going to find comments for a video knowing video ID. That's the main point. And for the second one, we are going to find comments posted for a user with a known ID, user ID. And now take a look. Do you think we could use one single table for these two use cases? Think for a second. The short answer is no. Because when we are going to write data, we will have everything what we need, video ID, user ID, it's all fine. But when we are going to retrieve data, we will not have enough information. And don't forget, partition key is essential. So it looks like we are going to need two tables, comments by video and comments by user. Yeah, thank you, Kannan, that's correct answer. And then we start to think of logical data model. For the table comments by user, we are going to have user ID as a partition key, creation date as a clustering column, and comment ID as a clustering column to ensure uniqueness. And then I will need to have video ID and comment by itself as the data columns. Then, comments by video. That's a little bit different for stores the same data. We have video ID as a partition key, creation date and comment ID as a clustering column, and user ID and comment as a data. So, What goes next? We go to physical data model. And here we start to think already at the very Cassandra table level. Take a look. Before, comments by user has user ID, creation date, and comment ID as clustering column. Creation date to know the date, comment ID to ensure the uniqueness. And on the physical data model, they are merged. There is one of Cassandra magics. Incredible type time UUID. It's kinda an UUID, universally unique identifier, but with time of the creation encapsulated within. So you can not only use it to ensure uniqueness, but also get time out of it and sort it by time. And that's incredible. So we needed to have like 5 fields. Now we need only 4 fields because comment ID will be time UUID. And now we just have one table much smaller. Good. And for comments by video, we have video ID, UUID, comment ID as a time UUID, user ID, and comment. Very well. And then based on this, we create schema definition. Create table if not exist comment by user, user ID, blah, 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 with primary key, user ID, and comment ID, and clustering order by comment ID descending. So that's how you can sort by ID and basically sorting by time of the creation. Very cool. And create table if not exist, comment by video. There is a really good question in Discord. I will read it. Seems like we are modeling along the lines of read patterns. Does it impact writes performance? Answer is yes and no. So in theory, now you have to write this comment when you created comment, adding a comment 2 times, but we do it with a batch asynchronously. So as all writes are very quick and all reads are very quick, and I run this operation asynchronously, I'm going to have write time mostly the same as it would be if I write one single thing. That's the answer. Thank you for the good question. Then we move on. And well, now we have our queries based on those patterns. Select all from comments by user when I know user ID, and select all from comments by video when I have video ID. A lot of people ask how to do it better, because now we have to update or insert into 2 tables. Don't worry, we have tools for that. We will cover it in the next steps. Don't be too much in a hurry. Now, time for you to do the job. So what we are going to do, for the exercise 4, you have to use data modeling notebook, and you can do it on your own, or you can watch the solution video, but I do recommend you to do it. Thank you. So, okay, sorry, one step back. Take a look. This workshop is an overview level workshop. If you are going to be successful with Cassandra, if you are going to pass the examination, you have to go to the place called academy.datastax.com. So DataStax Academy, we created especially for you to be successful with Cassandra. It's absolutely open project, no payments, no fees. You just go, register, and take your learning path. We have learning paths for the administrator, architect, developer, and graph specialist. Well, graph specialist, that's about DataStax Enterprise. Today we speak about Apache Cassandra. And you pass the required course. That's all together should be around 20 hours, if I'm not wrong. And then this course is done when you are ready for your exam, and then you are ready to be successful with Cassandra. It's not a simple thing. This workshop is overview level. Don't be in a hurry, take your time. Good. So, academy.datastax.com. Well. Next thing we are going to discuss very briefly are collections. We have three types of collections: set, list, and map. So map is kind of an associative array. You have a map with a key and value matching it, key value, say list, key value map, sorry. List has an order, so you can set things in the order you need to have. And set is just a collection of the things those need no order kind of things. Example table with set. When we speaking about videos, so Killer Video is a YouTube-like application, Cassandra reference application we use to show you how to work with open source Apache Cassandra and DataStax Enterprise. And in this case, we want to be able to set tags for every video. As we use set type text, we obviously aren't going to have any order because we don't need just text to be ordered. And we set it like set, and we specify type of things in this set we need to have. Like in this case, it's going to be just text. And then we have example set operations, like insert into Killer Video videos, specifying values, and also a set which looks exactly like a JSON JavaScript, simple object notation set of things. Then you can update it, specifying, replacing the entire set, and then you can easily add a thing to a set. List. List is a thing of ordered entities, ordered things. And in this case, we want to have actors ordered in the actors by video table. You know, that's very important. If you put a wrong actor to the first place in the actors list or vice versa, they are going to be very angry to you. Like, that's a serious shit. So be careful here. With list operations, we can insert a list, we can replace entire list, we can append list. Important replacement operation for us in the list, you can set and list item using just its ordered number. Example table with the map. You are going to have the map. First point usually going to be the text or integer, and second one is the value you are going to store. So with map, you may insert a map, which is still the same JSON notation. You may replace entire map, and you can add things to the map. Next one, very convenient type for us to use is user-defined type. So it allows you to create the type you are going to use, and that's in many use cases very convenient thing. You may create type like address, for example. There you can specify street, city, and state. And you can create table killer video users, specifying user ID, location, and primary key. We are going to use this user ID. So with UDT, we can insert a whole UDT, we can replace entire UDT, and we can change any kind of a single value, specifying it like as you see in the down here below, location.city. Very good. And also, maybe handy in many cases, you can read particular UDT field, select location.city from killer video users. In this case, you don't have to fetch the whole thing, so that leads to smaller network operations and saves us a lot of time. Counters. Counters are a very simple thing. It's an assigned integer. You need to count them like likes, views, and other things. And that's a very important thing. You may do only two operations with a counter, increment or decrement. First operation assumes the value is 0, and after that you can increase it or decrease it. You cannot set a particular value for a counter. Counters obviously cannot be a part of a primary key because we are going to change all the time. Counters are not mixed with other types in the table. So if you are going to use counters, data types of this table are going to be only counters. Value cannot be set. You can just increase or decrease. And rows with a counter cannot be inserted. You can't insert the exact value. Now that's important. As any operation is increment or decrement, updates are not idempotent. Counters should not be used for precise values, so like you aren't going your money to be stored in the counter value by your bank, and then when you are getting, I don't know, some transfer of $1,000, making increment 1,000 times is obviously a bad idea. Example table with counter. Well, we create a table with ID because we have to identify it, and have a views counter with primary key video ID. We have to keep exactly this format then updating. Set views equals views +1 or views -1. A pretty rare case. It's hard to unseen the video, but maybe with your application it will be possible. So, next one, advanced types exercise, and we will do it very quickly. So, you will have 10 minutes to do it, so let's start right now very quickly. I hope you have links already. Okay. So let's move on. You just did advanced types exercise, and we have to proceed. Good. So in this part of the workshop, we cover two very important tools of Cassandra lightweight transactions and Cassandra batches. And we start with lightweight transactions. First thing you have to notice is the word lightweight. There's not a traditional relational transactions you use it to have. Not like very, very not the same. Most important thing for us, if you use it to traditional relational commit, rollback, start, that doesn't work this way. That's maybe even a bit misleading name. That's not how it works. Let me show you. Sometimes insert or update operations must be unique. We don't want to change a value if it has been changed already. Sometimes we want to lock operation, like not to do it if we have changed the value already, or we want to make some comparison before changing anything. Lightweight transactions are solving this problem. It's kind of an if clause at the database level. And one very important thing, of course, anything like that will brings us to read before write. So we want to compare something. We have first to get value, compare it, and only then write. That's, of course, slower when it's simple write. So the typical problem you can solve with lightweight transactions. Imagine you have your application running in multiple instances. That's very often use case. And you have application instance A, instance of the database, and application instance B. I see some guys are having problems with Twitch. If you have problems with Twitch, then please switch to YouTube. We have some redundancy for you. So, sorry for the interruption. We have application instance A reading record 1 from the database. And we have application instance B reading the same record from the database. Then application instance A is going to change something on the record 1, making it an Y. And application instance B changes the same record. Then application A reads the same row and no changes. What the hell happened? Why I changed something and it's not available anymore? That's exactly not what you want to have. Like very similar case for the race conditions, for example. It looks very close. Who writes the first? Who writes the second? Last write wins. Giving the example, I'm reading from user credentials with the email newuser@gmail.com, and the table is empty. We don't have this user. When I insert into killer video user credentials, data of the user with lightweight transaction, notice the last thing, if not exist. That's the most important part for us. And in the metadata of the answer, you will have applied true. Okay. Applied column shows the result. So using the result object in your application, you may see if it was applied or not. So LVT created the row. And if we select from these user credentials, we will have this user. And then we are trying to insert a second customer with the same email, like some mistake happened. Password is different, but it will be not applied because applied was false. And also in the result object, you have email, password, and other things. So you can check and handle this operation at your application level. So row didn't change, password is still password A. Great. So in the lightweight transactions, in the if clause, you can use comparisons, checks. You can have multiple comparisons. In general, that's a very powerful tool, but take care using them at some reasonable level, only if you really need to, because read before write makes it slower. Good. Batch. First of all, as usual, Cassandra is a non-relational database, so SQL batch is not the same as in the SQL batch. Main reason to use batch is very simple. Then you have to change multiple values within multiple tables. As you use a denormalization, that's a very often used case. Then you have to apply multiple changes. And with a batch, you say start batch, apply batch, and you have multiple inserts or updates executed together. And they will do the job. And first question, how it works? Answer is simple. Batch is being submitted to the nearest node, and node persists the batch. If anything happens, even with this node, as soon as it will recover within the timeout for the batch, it will proceed and finish writing operations. Batch workflow is very simple. It repeats operations as long as it required and allowed by timeout definition, by timeout time, as they all will succeed. And it may look like a pretty weird approach, but with Cassandra it works perfectly, because with relational database you may very often run into the limitations of the data integrity checks, foreign keys checks. And there it's not the point with Cassandra, because we don't have any foreign keys. These are not possible on the very quick distributed system, predictably quick. And this approach works perfect with a batch. The only case you may have a mistake, like having a mistake in your CQL, but in this case it will be simply not taken by one and all. We and DevRel teams spent a lot of time trying to make a batch working wrong, and well, we didn't manage it too. Question, second question, is batch atomic? Answer is no. So it may happen what some of queries at some moment of the time will be executed, and some queries aren't. They're executed asynchronously, and it may happen what first and second query will be executed, third query will be delayed for any network issue you may have, which is a case on the clouds. It happens, well, everywhere. So you may ask for data from one table, another table, but yet another table at some point will not be updated. So with batch, you have to control it and not try to access the data before batch is completed successfully. Batch use a very strong retry method to make sure all operations complete. So in general, that's much better than anything you can try to implement on your application side. People asked me like if I can do batch-like behavior on the application level. Yes, you can, but there is no real reason. Cassandra already does it and does very well. If operation fails, client will be notified, allowing it to handle the error. And handle the error means handle at the application side. There is no rollback, and there is no distributed transactions like real transactions if you want system to be perfectly quick. So we have a last exercise for today, but it's already time for us to stop. So I will ask you to finish this exercise on your own or watch our solution videos. And now, few last phrases. First thing, if you like it with workshop, we have something very interesting coming up for you next week. Next week, at April the 22nd, we have Cassandra Developer Workshop, Machine Learning. It's going to be introduction into machine learning with Cassandra and Apache Spark. We use we use it to handle, we use Cassandra to handle tremendous amounts of data, and then Apache Spark to run computations, distributed computations in parallel over multiple computation nodes to make a real machine learning. So first part, we cover how Cassandra works. And second part, the biggest part, we handle what is the machine learning, what's Apache Spark, how it works, what are the machine learning algorithms. That's a very good introduction overview level workshop for the beginners, for those who want to make a first step into the machine learning. It's a hands-on workshop, so you're going to write your own machine learning algorithms and your own. Please join. I make it a little bit bigger. 22nd of April, Cassandra Developer Workshop, Introduction into Machine Learning. If you found us at the Eventbrite, you know what to do. You have it all at the Eventbrite by DataStax. Follow us at Eventbrite. Good. Next thing, if you liked our workshop, you going to do one thing for us. There is a team of us, 4 people implemented this workshop, and now you are going to do something for us. There is a survey we are going to send to you. And take it seriously. This survey makes our bosses happy or not. So go take survey, answer the questions. We send you a link very soon. You mostly probably already have link in the chat. Go answer those questions. Say thank you, and we are thank you very a lot for attending this workshop. Last part, to get your certification, as you passed all the steps and now watch the last video or do exercise on your own for lightweight transactions, please get this link, what's in all the applications should be delivered. Fill a little Google form, and our community manager will send you a voucher. So you will have your voucher very soon. And then what's next? First, join academy.datastax.com. As I told you, that's an overview level workshop. So take the full learning path for the administrator or developer, depending on what certification you want to pass. There is a certification for admins and developers. Take the one you needed. If you have any questions, my friends tell me you've asked 1,000 of different questions during this workshop. Thank you. Keep doing that. Best place to keep doing that without any interruptions and be able to get answers not only of our crew, but also of the whole community and other things is the community.datastax.com. Simply speaking, community.datastax.com, it's a Stack Overflow for Cassandra-related questions. And there are some very smart and experienced people able to answer your questions. So, connect with us. We do a lot of great events, not only relating the Cassandra beginners, but some more advanced topics. So follow us at DataStax Devs, Twitter, Twitch, YouTube, other things. We are here for you. And to get everything related to this workshop, you have slides and code for this course available at github.com, DataStax Academy, online Cassandra workshop. I repeat, those busy and sad times, we may get some issues. Site reliability engineers of DataStax, so one of the best engineers in the world about the Apache Cassandra, one of the biggest developers for the Apache Cassandra, offers Cassandra cluster health checks and other consulting things regarding the Cassandra cluster running for open source Apache Cassandra completely for free. And that's a really rare occasion. Trust me, usually it's pretty expensive thing. So you can write to keep calm at datastax.com. If there are any free slots left, you will get your chance. So training courses at the DataStax Academy. It all depends on your learning path. So go to the Academy and it's all explained in the learning paths part. Killer video reference application. If you want to see the examples, how do we work with Cassandra? How do we work with DataStax Enterprise Graph, for example? It's all implemented at the Killer Video application, killervideo.com. And it's open source, of course, so it's available at github.com/killer video. So get it, take a look how it works. And watch out for our upcoming events. At 22nd of April, we have machine learning with Apache Cassandra and Apache Spark. And on 29th of April, we have Cassandra Kubernetes operator. So Kubernetes become a #1 for these kinds of a workload. And of course, DataStax recently released a Cassandra Kubernetes operator to handle with Cassandra and DataStax Enterprise. Thank you, ladies and gentlemen. It was great. We are very happy you joined us. And we will do this workshop again. So if you have some friends who are also would be interested, ask them, send them to our Eventbrite account to subscribe for events or DataStax devs, and we will publish all the information regarding the upcoming events in the future. Thank you so much. Thank you for questions. Thank you for your attention. It was a great pleasure to work with you.